Welcome back. In the previous video, we discussed the role of NLP in data science. In this video, we will look at the role of deep learning in data science. So let us get started. Well, have you ever heard about deep learning? Those with some interest in computer science are most likely familiar with the term and have read a few lines about neural networks. Otherwise, you are probably asking, what is deep learning? Why should I be interested? What is deep learning? Deep learning is a type of machine learning and artificial intelligence that imitates the way humans gain certain types of knowledge. Deep learning is an important element of data science, which includes statistics and predictive modeling. Now, it is extremely beneficial to data scientists who are tasked with collecting, analyzing, and interpreting large amounts of data. So deep learning makes this process faster and a lot easier. In simple words, deep learning can be thought of as a way to automate predictive analytics. While traditional machine learning algorithms are linear, deep learning algorithms, they are stacked in a hierarchy of increasing complexity and abstraction. Deep learning uses unsupervised data. There is no need to feed the computer with how to classify or treat the data because it learns and thinks on its own based on the algorithms of the deep learning scientist. It starts gaining experience by using multi-layers in complex structures, just like our brain neurons do. Deep learning techniques require high-performance computing power to process massive amounts of unstructured data through deep learning frameworks and algorithms. Up until recently, high-performance computing, or HPC, was only available to the largest budgets for hardware and talent to optimize scientific codes on HPC platforms. Since the year 2006, the graphic processing unit, or GPU hardware, has emerged from more expensive, compute-intensive graphics applications to more affordable general compute devices available to any compute-intensive applications such as deep learning. To understand deep learning, imagine a toddler whose first word is a dog. Now, the toddler learns what a dog is and is not by pointing to objects and saying the word dog. The parent says, yes, that is a dog, or no, that is not a dog. As the toddler continues to point to objects, he becomes more aware of the features that all dogs possess. What the toddler does, without knowing it, is clarify a complex abstraction, the concept of dog, by building a hierarchy in which each level of abstraction is created with the knowledge that was gained from the preceding layer of the hierarchy. Now we will look at the applications of deep learning. The usual applications of deep learning include natural language processing, image processing, speech recognition, etc. Natural language processing is the process of having a computer understand what you are saying, useful for translation, discourse analysis, and text summary. Image recognition allows images to be easily searched, sorted, and segmented for object detection, which is highly useful to scientific applications, e-commerce, realtors, social networking, and advertising. Speech recognition is when you tell your car to select a radio station, tell your smartphone to type text, or tell your phone to dial a number. Now, many companies, including Apple, Facebook, Google, IBM, Microsoft, PayPal, Yahoo, Twitter, and whatnot, and many more companies, they are all using deep learning technologies. So I hope that all of you are now clear with the concept of deep learning. In the next video, we will look at the difference between machine learning, natural language processing, and deep learning. So till then, stay tuned, stay healthy, and keep learning. Bye.